E quindi registra sia presentazione che...
Sì, sì, che è quello che dice.
Ok.
L'esterno, spero. Ok. Magari introduco brevemente il professor Dmitry Koroliouk, Professor Dmitry Koroliouk from National Technical University of Ukraine, Kiev, who's going to give us an introduction into neural networks and deep learning. Thank you very much.
So, I will expose the problem of artificial intelligence from the point of view of engineering science. That is because there is a usual discussion between engineers and mathematicians, or between medical science and mathematicians. That I was testimonial that when one engineer and one mathematician begin to discuss, and engineer express some need to develop some system, and the mathematician naturally ask him, so please explain rigorously the problem, and the engineer never can explain rigorously the problem by the simple reason that it is something like consequential approximation to the truth. So he cannot impose the problem correctly and exactly as mathematician expect. As the result of such type of discussion is that engineers begin to develop mathematical system and write down some mathematical model and then to program this model. Such example was I saw in development of cellular telephony, when a lot of mathematical problem arose, and for example, statistically LPC, linear predictive codifier, which is a codifier of voice flow, digital codifier of voice flow from audio to digital, and it should have variable rate of bit, because we have variation, time variation of possibility to transmit and to receive, because our channels can be saturated, can be more free, so we can have more bandwidth to transmit and to receive with more velocity, and that Nyquist theorem is Nyquist theorem. Tell the maximal bit rate which you can transmit or receive. And so engineers also have written all the code of this telephone. And the first telephony, the first cell telephones with button, yes, task, had about 2 million of lines of code. Even such small and such stupid telephone had the GSM, had the simplest, had 2 million line of the code. The same thing happened for the artificial intelligence. So the first task, historically, the first task was from the American postal service, yes, postal offices, to recognize the code of different cities and places in the United States.
Zip code.
Yes, and since in the United States, the major part of all actions, administrative release of premises, release of documents, and so on by the post. Yes, there is a very big flow of postal exchange in the country, and the postal office should have ask for automatic recognition of the index, postal index of the plate on the envelope, and automatically to sort this post. So it was the first task. Now, first introductive words. So, how to distinguish cat and dog from the photo? From the photo, we cannot write any program, because we cannot formalize the task, and the computer needs the very rigorous formalization of what you want to do. Otherwise, doesn't work. So, on the one hand, it is next to impossible to imagine what is the answer of this problem. But also, we know that even for small baby, the mother can tell to small baby, this is dog, this is cat, this is dog, this is cat, and after several attempts, the baby begin to understand this is dog, this is cat, and what is the difference. But it is not possible to describe formally. You see, the same problem. Male face and female face. How to distinguish? There is no rigorous rules, and it is not possible to imagine ever to write down something like the difference mathematically to express. And the same problem also when we should automatically recognize, for example, it is typical writing on the post mail envelope, and we should recognize automatically these digits. But for example, several persons can write in absolutely different manners. So how to recognize anyway the index? So after of such efforts, one can assert that the neural network, like the basis of artificial intelligence, is one of the most beautiful programming paradigms ever invented by man. So it is some other thing of programming which can bring to recognize a lot of things without formal rules. And it is And it is based on pure mathematical reasons. And it is based on mathematical formulas. It is based on optimization of our mean square error characteristic and some numerical method of manipulation the calculus. So what is the difference between the classical approach with rigorous rules and the neural networking approach without rigorous rule? What is the difference between the computer and a baby who can recognize cat and dogs, male face from female face? The difference is that some automatic system make some precise algorithm basing on some mathematical proceedings and calculate the result. In the second case, one proceeds not calculus, but recognize the pattern, yes, the schematic pattern of the case. So it is something like pattern recognition. And the pattern recognition is very important in face recognition, for example. Then, for example, automatic translator, automatic bot, computer bot system, which recognize some problem and then to pass this signal to the office of competence. It is speech recognition. Speech recognition is very. There is voice recognition. It is something like individuation. The speech recognition is the recognition of the word and automatically register it from the speech. But from a person to person, the speech is very different. And the spectral or logarithmic spectral or other very heavy algorithms does not return good results. For example, for Telecom Italia, for other entities. But when the neural networking system begin to move and to progress, this type of result was more achievable, and the hardware, which the electronic devices, which were able to recognize the content of the speech of the persons, and it become very simple, respectively to the spectrum analyzing this method of windows for different boundaries and so on. So let us pass to the problem of recognizing. The solution has been done of ex-Bell Laboratories in the United States. Then it named AT&T company, AT&T company. Bell Telephonic first, the name. And they model the neural network of our brain. So now let us tell about this story. So consider the postal index. Most of person can recognize these numbers. Why? Because in each hemisphere of human brain, we have a primary visual cortex, V1, which contains 140 million neutrons connected between them, which with tens of billions of different pathways between them. Then we can assert that there are other visual cortices, V2, V3, V4, and V5, which doing progressively more complex image processing inside our brain. The difficulty of visual pattern recognition. For example, consider the typewritten 9. Yes? How we recognize its shape? Approximately. A 9 has a loop at the top. Yes? A loop at the top. And a vertical stroke in the bottom right. But the position can vary, and the angle of pendants can also be different. How to express it algorithmically to recognize 9? The solution seems to be hopeless, but neural network approach which uses a large number of handwritten digits collected and prepared for elaboration, can do such a problem with a big fidelity, and not soltanto with a big fidelity. Even the neural net, after so-called deep learning, what is we shall tell after about the learning of this problem. It is automatically learning. Can recognize even some characters, truly recognize, which we are not able. So, and generally, we can do some assertion. What is the potential of artificial intelligence? Suppose we have some set of characteristics of some object, and set characteristic of other object. Okay? We have characterized by some parameters and characteristics one object and two. So, if we can find some opportune space and some matrix in this space, yes, matrix, so distance between points, we can then divide these two clouds of characteristics by some line of or some hyper plane or something like, and to divide these characteristics. But when these clouds not only intersect, but one inside other, how to do, what to do. And neural networking in incredible manner can distinguish these characteristics which absolutely overlap after the deep learning. We cannot, but the artificial intelligence, yes. How to do them? So the neural network after deep learning can catch incredible and invent incredible algorithms of solution of problems which we cannot imagine. That is why, by the way, that is why there are now ethic code of treating the neural network to avoid the singularity of developing. What does it mean, singularity of development? As we know, the artificial intelligence now can play chess better than the better representative of humanity. Yes. Not exist and not possible to exist Grossmeister in chess who can win the modern system of play chess. Okay, it is impossible. And what is the singularity? Singularity is the moment when artificial intelligence begin to invent and to move some development, and we cannot, and we have not such big velocity to understand, and we begin to not understand what happened, and such situation can go out of control and can bring a lot of problem. So that is why there is now a code of comportment with artificial intelligence, and there are a lot of restrict to use it. Okay, now such development is crystallized in toolkit, different toolkit, but very famous and very wide used toolkit contained in Python programming package. There are standard libraries, and who know the problematic can have a constructor like a cube for children, can assemble some models and have immediately artificial intelligence. Now it is very easy to do. So it is a small fragment of a big American database of different states of population who make typewritten numbers on some boxes. So the idea is create a network type structure which analyzes the digits as patterns, and then develop a system which can learn from those training examples. So first we should to construct a network, neural network to guess, to imagine, to guess some its topological view, and then to begin make some training, some specific training, this very clear criterion, mathematical criterions, which learn how to recognize typewritten digits. So the objective are to recognize handwritten digits with an accuracy of 96% without human intervention. This is a model example and a good prototype for demonstrating the principle of how the neural network work. So we begin from this historical example, but it contains all the fundamental features of neural networking and deep learning. So it is integral components of artificial intelligence. This is so now it is clear that when we begin to consider all the variants in the typewritten, it will be the immense computer variants. It is trillions of different variants, and we should invent something to short our way to solution. Otherwise, we have not such resources in time and in computing capacity to do such problem. Later, we will discuss this idea may be applied to other problems, like computer vision in speech, language processing, and other domains. For example, the Google research, you know, Google research, you can ask something like, what is the best dishes in Texas region, and it immediately give you a lot of variants, but relative variants. How can possible to achieve such big velocity immediately from terabyte information immediately to find immediately a result? It is some action of artificial intelligence in which Google group is very strong and leader. So, from some fundamentals. So, this solution begins from the modeling, mathematical modeling of how our brain works. And the first fundamental element is the perceptron. Perceptron is our neuron, and perceptron in programming is a type of artificial neutron. Perceptron were developed, and the model of perceptron in 50s and 60s by scientist Frank Rosenblatt. It's inspired by earlier work of Warren McCulloch and Walter Pitts. And the main neuron model use in consideration one called the sigmoid neuron. This is so-called response function, and it is very important moderator for deep learning possible. How do perceptrons work? So this ball is perceptron. It is the model of neuron cell. There are several single binary input, and there is some binary output. So a perceptron receives some binary entry, yes, x1, x2, x3, can be a lot of, can be any number of input, and output, and give that an output. It can replicate the output, but output is always one result of processing of such inputs. Example shows a perceptron with 3 inputs and 1 output. Rosenblatt proposed a simple rule to compute the output. He introduced the weights coefficient W1, W2, and so on. It is real numbers. It is a weight of importance. Yes, and the neuron output 0 or 1 is determined when we defined firstly some threshold value, and the output is 0 when the weighted sum of inputs is smaller or equal to the threshold value, and 1 if it bigger than the threshold value. It is absolutely a repetition of how our nervous system in our brain work. So some small inputs does not take into account, but when we have some critical level, and when in inputs the sum of inputs become bigger than this critical level, yes, threshold, begin to give 1. So it eccitazione lose part from it shut. Shut means that in jargon, shut means that it assume 1 and then to this 1 is the state of this cell. This is the basic mathematical model which corresponds to real medical mechanism, real biological mechanism. So, example 1. Suppose you are trying to decide. It is very simple but very significant example. Suppose you are trying to decide whether or not to go to a party. Okay? You might make your decision by weighting up the 3 factors. Is the weather good? Then, does your boyfriend or girlfriend want to accompany you? And 3, is the party near public transit? For example, you have not your own car. So let us introduce three factors by corresponding binary variables x1, x2, and x3. So is whether good or bad, does your boyfriend and accompany. So x1, assume 1 if the weather is good and 0 is the weather bad. X2, 1 if your friend wants to go and 0 if not. And similarly for x3 for public transport. Yes, near 1, not near 0. And your preferences, for example, W equal to 6, W2, W2, 2 and 2 mean that you really love, yes, you heard bad weather, and there is no way you'd go to the party if the weather is bad, even if your boyfriend or girlfriend is uninterested and the festival is hard to get to. No, you yes, bad weather is bad for you. So choose the threshold. Yes, the critical level is 5. With this choice, the perceptron, which is figurated before, yes, this perceptron with this input and decision is 5. Outputting 1 whenever the weather is good, and 0 whenever the weather is bad. And no difference if your boyfriend or girlfriend come with you, and no importance if the public transit is near or not. By varying the weights and the threshold, we can change the preferences and change the decision. And it is a fundamental principle for how the artificial intelligence works. So, for example, suppose we instead choose a threshold of 3. Then the perception would decide that you should go to the festival whenever the weather was good or no. Yes, was good, or when both the party was near public transit and your boyfriend or girlfriend was willing to join you. In other words, it be a different model of decision making. So by simple variation of your threshold and the coefficients of importance, yes, the weighting coefficients, you cardinally change your decision model. Dropping the threshold means that you are more willing to go to the party. Yes, if you move to upper. Okay. So, perceptron is not a complete model of human decision making, but it should be plausible that a complex network of perceptron could make quite subtle decision. It is very simple example, but if we produce some more complex topology of such network, we can get some very subtle, very complicated decision. In this network, the first column of perceptron, you see, receive inputs. Every perceptron receive inputs. And we call this first row of perceptron the first layer. And it make very simple decision by weighting the input evidence, like in the example before. What about the perceptrons? What about the perceptron in the second layer? So we have the first layer of making decision. Then the primary decision of the first layer will move to the second layer of perceptrons, and they make some more profound analysis. Okay, with some coefficients, of course. What is about the perceptron in the second layer? Each of those perceptron is making a decision by weighting up the results of elaboration of the layer before. Of the decision making. In this way, a perceptron in the second layer can make a decision at more complex and more abstract level than perceptron in the first level, and even more complex decision can be made by the perceptron in the third layer. In this way, a many-layer network of perceptrons can engage in sophisticated decision making. And I can tell you that now there exist examples of. We really in the Kyiv Polytechnical Institute used some neural network with about 1,000 layers, and there is a very big volume of calculus. But there exist some examples when there are several thousand of layers of such topology. Okay. So now let us rewrite mathematically more from our operativity this ratio, yes, between threshold and the weighted sum of our inputs. So the ratio sum by J, it is summation for one layer, yes, summation for J W J xj, yes, xj input and W is the weighting coefficient, yes, coefficient of importance. Should represented by the scalar product. Now we rewrite such sum as a scalar product of two vectors. It is very compact and very useful for programming. Now we can define the vectors one, and then very compactly we can write the relation. So it is scalar product, yes, and WAX are corresponding vectors with the corresponding dimension, yes, whose component are the weights and inputs respectively. Also better to replace what's known the perceptron bias. So to rewrite the threshold as a bias, it is a simple mathematical operation by shifting the by shifting the threshold to the shift bias. So the equivalent formula output, you see now. You remember, yes? Firstly, we have defined the response in the formula 1. Yes, output is 1, 0 if the summation is less of threshold, and 1 if it is bigger than threshold. Now we rewrite equivalently this formula in the following form. Now we optimize the mathematical formulation for better calculation. Output is equal to 0 if the vector of weights multiply scalar product to x, yes, vector of input, plus b, smaller or equal 0 and bigger than 0. So we have substitute threshold to b, to bias, to shift, to move. The same thing. So bias have contrary sign, but it is equivalent thing. So you can think of the bias as a measure. Yes, firstly, our reasoning was around the threshold. The threshold bigger, it is more preferred. Now the threshold is not now the bias. As a measure how easy it is to get the perceptron to have output 1. Yes, how so? It is a measure. Yes, bias is a measure how easy the perceptron can assume 1. It leads to the further notational simplification. Because of this, the reminder we won't use the threshold. We shall always use the. Yes, we now drop the threshold and only we use the bias. So we have seen perceptron as a method of weighting evidence to make decisions. Another way perceptron can be used as to compute the elementary logical functions we usually think as an underlying computation function. This point is very, very important. The idea is that every perceptron can present some elementary cell of Boolean logical proceedings. So we can transform our network in a computer with some cells itself without computer. And it can do the same logic as the classical computer. It is a very, very particular case, but very, very interesting. For example, let us consider the perceptron, you see? The perceptron with the bias 3 and weight coefficients -2 and -2. Then, you see what succeeds. Then we see that the input 0, 0 produces 1. Because if we add and making the summation by module 2, it is 1. Here the asterisk means the simple multiplication of numbers. Similarly, inputs 0, 1 and 1, 0 produce output 1, but the input 1, 1 produces output 0. So it is very, very simple wire. But what is it? It is AND, negation of AND, not AND. But NAND is very important Boolean operation. NAND is so-called shifter prime. There exist in Boolean logics, which is the base of all computer construction, AND, OR, XOR, NOT, and so on. So there are some Boolean operation, but there are two operations which generate all of this, AND, NOT, OR, XOR, and so on. There are two elementary operations which generate all possible operations. It is this shatter prime. It is NAND, not AND, and not OR. So-called Pierce arrow also. But now let us look at NAND. So NAND perceptron implements a NAND gate. Then, for example, how can we construct a gate which executes the OR, the operation OR? We considered a system with 5 perceptrons NAND, which one line made a summation by model to x1 plus round plus is summation by model 2. And also it produces the carry bit 0 or 1 of the next carry. The logic circuit calculation, the bitwise sum 1 plus round x2, so it is summation by model 2, as well as the carry flag, which is 1 when both x1 and x2 are 1. That is, the carry flag is simply the result of bitwise multiplication of x1 and x2. To get equivalent network of perceptrons, we replace all NAND gates with a perceptron with our weighting coefficient and bias value as 3, 3 and -2, -2 between them, and then we have the same result. It is the operation OR. But since we have two inputs, here we have the two inputs with a weight -2, -2, we can substitute it. A simple one connection with the weighted -4. Other remain like. A network of perceptrons to simulate a circuit containing many NAND gates, which generate all other Boolean operations. And since these gates are universal for computing, therefore perceptrons are universal for computing. So now the idea is the following. When we then do some deep learning, the system automatically adjusts the weights and the biases, and it can invent some Boolean operation which we can not imagine. And specifically do it for resolving some operation. That is why artificial intelligence. So by such simple manipulation of the coefficient, it can do a lot of Boolean operation which we don't know. So we can develop learning algorithm that can automatically adjust the weights and biases in a network of artificial neurons. This adjustment occurs in response to external stimuli without without the direct intervention of the programmer. The programmer only formed the topology of the neural network and only to define the initial parameters and then the procedure of training. The training is the adjustment of the parameters in the base of the training samples. So we should have some preliminary information, so-called training sample, not very small. And then the procedure to deep learning is the procedure of nothing else that to modify the parameters of the system. Yes. So weight coefficients and biases in all the nodes of this network. And this is all. Allow us to use artificial neuron in a way that it is radically different from ordinary logic gates. So the system can adjust the coefficient in such a manner which executes some very complicated logical proceedings which we cannot even imagine. Instead of explicitly writing out a circuit from NAND gates and others, our neural networks can simply learn to solve problems, sometimes those for which it would be extremely difficult to directly design a conventional circuit. So we can invent some specific processors for specific problem, which our neural network can optimize for some special calculating. Now, the other step, the other small step is sigmoid neurons, so-called sigmoid neurons. Before we talked about integer valued weights coefficient and the biases shift coefficient, yes, bias parameter bias. So the significant, it is a number which elaborate inside of every node, every perceptron. Let us do some small interruption, technical interruption. I take my mouse, which is much more convenient to expose. 1 minute.
Yeah, no problem.
opening card. So let us continue. So now, for implementation of learning algorithms, it is necessary to provide the property of smoothing our change, that the small changes will imply a small change in the output of the network. And it is possible to do in some different ways, but always by choosing some weighting function at every node topology. How to do? For example, now let's see W, yes, plus delta W. So small change in any weight or bias. So weight is our and biases. So every node should have its weight and yes of input and bias. So the value of in the node. And such W plus delta W. W is generalized vector, consists of all weighted coefficients and all biases of nodes. So such small increment should lead to the small output. We should have some procedure of smoothness to learning. If we have big jumps, it is very big problem. We should move to our solution gradually, without the situation of jump. Otherwise, we never can get good result. So the idea is such. So the small change in input should imply the small changes in output. For example, why it is very important. For example, we have misclassified the image of 8 to 9. So we have begin to train, and we made our system worse than before, that perhaps train some new feature, but the previous feature is become worse. It is not possible. So we should have some very graduate approximation to our result. But from one side, it should be graduate, but on other point of view, it should be enough fast. So we should optimize our training process to get good results. And there are a lot of new inventions how to do it. So it is a very difficult task not to break our previous training by insertion of new factors. So we should avoid by only cause such catastrophic circumstances. So we depict sigmoid neurons in some way as the perceptron. Yes. Also, there are several inputs, for example, 3, but not necessary. Since any number of input and output. What is the output? Is the calculus with bias and inputs and weighting coefficients. So the sigmoid neutron inputs x1, x2, and so on. But instead of being 0 and 1 as before, they can take any values between 0 and 1. So now any number between 0 and 1 are possible like input, like the value of input. And the weight parameters W1, 2, and so on are and overall basis also. But the output is not 0 and 1. You see? So we now permit to make any parameters to take a value between 0 and 1, but the output is the following now. So-called sigmoidal function, you see? It is so-called logistic function. Or in coordinate forms, we can write it in the form of scalar product. The algebraic shape of the function sigma is the following. There are some probabilities of you. Yes. So what is look like? It is look like the distribution function of normal Gaussian distribution, something like. Okay. But this is the logistic function, so-called. So logistic distribution should be similar. It is very interesting thing to study. What is the difference between the normal function and logistic function, like the property? Because the density should be also the proper and so on. The function sigma is also called logistic function. Yes, it is typical logistic function. So the difference between perceptron and what is S? And sigmoid neuron, yes, is the following. Output belong to the interval segment 0, 1, and for perceptrons, output or 0 or 1. The smoothness of sigma means that the small changes of weighting coefficient, yes, of increment in the weighting coefficient, and small increment is in bias value, yes, will produce a small change of the output in the output from the neuron. So something like this. Delta output is about partial derivative of output by summation by all weight coefficients multiplied by increment of weighting coefficient plus partial derivative by bias, output by bias, multiplied by increment of bias value. So delta output is a linear function depending on weights and the bias delta B. So depending on the increments of weights and the biases. That is one can achieve any desired small bias in the output by moving the parameters. And again, I repeat that for us, fundamentally important not to have no jump of the resulting function. So our iteration for.
Yes. Can I ask a question?
Yes.
Why do you choose specifically the sigmoid function and not any other smooth function with values between?
In fact, it was the first remedy for moderation of the process. Yes, for smoothing of process of deep learning. When we have the stability of the learning of network with good results. There are some other very interesting functions that we can apply.
Okay.
But there is stepwise, for example, 0, 1. Yes, it is for the perceptron classical. And for this, there is some tangent, hyperbolic tangent function also very good for such. But there are a lot of other functions also very good fit. It is not, it is obsolete information, but it is very significant because Now the courses of neural network are based on the programming on Python, but I want to expose you mathematical foundation of this problematic. You see, I will not tell eventually to some libraries of Python system for construct modern program. Only I will tell you about the mathematical optimization for calculate of the system, and you can perhaps choose some of your problematics in your field of interest, because the word yes, is constructed by similarity one to other. So we can get some new ideas from the similarity of other. Okay. So that is one can achieve any desired small bytes in the output by moving the parameters. But we should, our strategical task is to avoid some jump of the function. The architecture of neural networks. Consider the following network. We have practically three layers. One, yes, input layers. Then the second, it is so-called hidden layers. So there are input layers, yes, all the inputs. It is our request to neural network, yes, our request. And then output is the response of neural net. And all intermediate layers are, by definition, are called hidden layers. So if input with input neurons, output which give us the result. Yes. Now our output result is only yes or not. If we should have some more result, for example, to recognize handwritten digits. Yes. In this situation, we should have 10 output perceptrons. First is 0, the second is 1, and up to 9. So it consists input layer, output, and hidden layer. It is not output and not input. For example, it is more interesting for recognition of digits, but not precisely our case, because the output should have 10 output neurons. So the network here, input layer hidden, yes, all intermediate are hidden, and output layer, this response, is called multi-layer perceptrons of or MLP. But really, it is only the defect of terminology. It is historical defect of terminology, because really it is intended that all this neuron, not perceptrons, but sigmoid neurons. So now let us reason about how to return to our primary problem of handwriting recognition of numbers. So again, we have the index, typewritten index. Let us break the image into 6 separate images. On the envelope there is boxes in which one should write down. But now it is this problem, it is so-called segmentation problem, is completely resolved. No problem. There is no more problem to write properly inside these boxes. Once image has been segmented, then one needs to classify each individual digit. For example, for the first digit above, yes, 5. To recognize, now let us propose such 3-layer neural network. And such network can recognize typewritten, handwritten digits with the probability 0.96. So, as input layer, we have 7,084 neurons. Why? Then I explain a little bit later. It is so-called pixels of our boxes. Then I explain what is. Then there is some hidden layer, and it consists 15 neurons. Here we reported only 6, 7, 8 neurons, but really it is 784 for simplicity. Then 15 neurons, and then what we need, yes, output layer. Is it 0? Is it 1? Is it 2? And so on. In ideal situation, yes, ideal situation should be 1 and 0, 0, 0, 0. It will be in the perceptron, for example, which correspond 5, 1 means that the reply of the response of our neural net is the digit is 5. So we now write down such topology. So all neurons are connected with all. Okay. Then we divide every handwritten box into rectangles, 28 by 28. So 784 called pixels. So we divide this box by definition. We have made convention between us. Yes, 28 by 28. It is so we divide 28 to 28, and then we scan the pixels in this box. Yes, in gray scales. So the value 0, 0 representing pure white, and 1, 0 representing black, and all the intermediate means that something like gradually darkening shades of gray. And so we make the string of this data scanner, and then begin to send to this perceptron. And then we should get the result here. Of course, firstly, doesn't work anything. We should firstly to train, yes, to learn, to teach this deep learning, to teach this network. Okay. The second layer is a small hidden layer which contains only 15 neurons. How much neurons should be in the layer, accepting input and output, is not clear. And there is not a science about it. There is not criteria. It is something like intuition and good sense. So we can move some topology, and in order to improve the results, only in this situation. Okay, if the first neuron fires, yes, so they become 0, become 1, yes, and output about 1, because of course by sigmoidal function of decision, in any neuron there is no 0 and there is no 1. Should be something. So the better response. What is the value? Major value is the response at the place of our digit. So has an output 1, then it will indicate that the network thinks if the first. The digit is 0, yes? So it is 0, 1. If the perceptron fires which corresponds to 0, yes, it is near to 1. So the response is that it is 0. The issue is that if the second neuron fires, it will be 1, and so on for other neurons. Why we use 10 output neurons when it is enough to have only 4 neurons and which codifies 16? Why? Because we have symmetry, uniformity, symmetry. This is absolutely symmetric. If we codify 10 by 4 bits, we have abundance, yes? Not 16, but we should put only 10. And other 6 remain free and can break our play for optimizing. So it is not good to codify in such redundant, yes, abundant manner. To understand, we should look at the work of the hidden layers. Also the reason is the work of hidden layers, but the work of hidden layers is interesting autonomously also. Why? Consider first output neuron that is trying to decide whether or not the digit is 0. It does this by weighting up evidence from the hidden layer of neurons. Okay? What are those hidden neurons doing? Suppose that the first neuron in the hidden layer detects whether or not an image like the following, a part of 0. So, what do the hidden layer? It segments a part of digit and recognize or not some pattern of our object, our digit. If yes, something similar, it elaborate some bias. Yes, some response. If not, response should be very small variant. So it can do this by weight increase of input pixels which overlap with such image and less weighting the other inputs. So the priority of 0 when there is some pattern and the hidden layer observe properly such property. Okay. And other in perceptron in hidden layer, you see, look for also such fragment which are very similar that we have captured 0. That is why that is how work the hidden layers. More hidden layers, more fragmentation, and more thorough, more subtle analysis of the shape. Yes, of some figure or image. So if all 4 of these hidden neurons are firing, then we can conclude that the digit is 0. If we had 4 output neurons, then the first neuron would try to decide what is the most significant bit of the output digit. And there is no easy way. So there is some confusion when we have some codification of a number and some digit are out of significance. We have some confusion of the weight and bias values, and there is no stability of learning. So the minimality of number of output is very important, and the symmetricity is very important of the topology of our neural net. Okay. Learning with gradient descent, and this is a very important. This is a very important factor. Having this a design of neural network, how to recognize digit. One should use data set which name is MNEST. It is United States National Institute of Standards and Technology. It contains about 60,000 images to be used as training data. So the United States Institute of Standards involved some layers of population, yes, some state of population, and different gender, different age, and they have written 60,000 image of handwritten digits. And this is a small subset of a big data. And they keep 60,000 images for the training data and 10,000 images to be used as test data. So it is something not trained but should be recognized as quality verification. And such typewrittens, you see, has a preparation of any box as 28 per 38 grayscale pixels image. So not only any boxes with this digit, but also grayscale pixels are ready. So one has training input as 784 pixels. Yes, string. It is a 784 dimensional vector. The desired output is 10-dimensional vector. Yes, 0 or 1 or 2 or and so on. So if x corresponds to 6, so 0, 1, 2, 3, 4, 5, 6. So vector transposition. The T means transposition. So let us consider line vector and then transpose it is row. No, row it is column vector. For training of the neural network, introduce the cost function. It is very specific thing. The cost function. Cost function is really it is mean square error. Really, it is mean square error. But what is the cost function? Cost function means that when cost function is near to the 0, we correctly can recognize the digit. When we have more error of our recognition, our cost will increase. So that is why the mean square error of recognition is called cost function. It is very good function because it is smooth, it is quadratic function, and for some reason of sign, yes, plus or minus, it is very important for gradient method of optimization in the future. So, what is this function? Function is 1 divided by 2n, summation by all x. The x now we use. So, it is not the norm. It is not the norm, but unfortunately they use such norm. But in some sense it is Pythagore norm. Now I explain. So W are all weights in the network, all weights. W. B, all the biases. And the total number of training inputs. Yes? How much specimens we have. A, the vector of outputs from the network when X is in input. A. So the output which we receive. The notation V, norm V, what is it? It is usual length function for a vector V. As mathematician, it is not very wide you use it. It is some programmistic engineering notation. And what does it mean? It means the following. If we have the vector A, B, okay, with two components. Let us construct orthonormal basis, two-dimensional, yes, A, B, and hypotenuses is, questo è D, for example. D, Pythagore theorem. So there is the difference, vector difference between y of x, yes, minus our result which we obtain. Then we make the hypotenuses and elevate to quadratic. And then we make summation on all x. On all x. On all. You see? 10-dimensional. X is input. So C is a quadratic cost function. It is also sometimes known as a mean square error or just MSE. So it is really mean square error. And it is very good, smooth differential function. So our aim is to make this cost function possibly near to 0 when y of x is near to a. When we analyze and get good results, so should be our cost function near 0. So the aim of training is to minimize the cost function by all weight function and all bias function. I think the algorithm of gradient descent I should move to tomorrow because it is big block. So let us finish today. If you have some question.
This cost function, it seems to be a function of weight and bias, but then in the mean square, the formula, I don't really see it. Although we know that y would be dependent of, it would be a function of weight and bias. So it's a result of the weight and bias. But I don't really see it literally in the formula. The cost function,
you see,
seems to be.
You see, we write down now the criterion which we should minimize, and our aim. What is the quality of our training of network? With the quality of our training of network to minimize this function. To minimize this function is very, very difficult because it is connected with big dimensions. For example, one should calculate the second partial derivative of 1 milliard of values. So there is some very clever methods how to bypass the big dimensionality. And it is very interesting pipeline method of calculation with some prevision with some prevision. So we, in the prevision of the future compartment of our function, we immediately move the argument according the joint gradient to minimize. I will explain that tomorrow.
So in this notation, that will be A, which depends on W and T, right?
A, the vector of outputs from
Yeah.
the network.
There, the dependence on W and B is in A, right? This form is hidden in A.
Yes, all these functions depend on bias weighting coefficients. For simplicity is not only for simplicity there is here, but it is like exclusion. Usually not use they doesn't use only C. Means that depends on the parameters. Why they ignore this parameter? Because with this parameter really it is not possible to train. There are too much. But even for these topologies, but the modern neural net it is enormous. There is enormous connections and a number of neurons. So we cannot consider all the parameters. We should bypass this dimensionality. It is very molto furbo come fatto. Furbacchioni. Cioè le cose enormi loro riescono a ridurre, diciamo, milioni di volte. Una cosa molto interessante, come ingegneri sono riusciti a bypassare, diciamo, di quella. Mai fanno, diciamo, la cosa dritta, proprio, non si sbattono la testa a cemento armato, fanno sempre le cose bypass. Perciò non vedono neanche i parametri, perché dicono sì, questi parametri, però in realtà non possiamo considerare sono enormi.
Sì, no. Per rispondere alla sua domanda, la tua notazione è A, piccolo, che contiene i parametri.
Sì. Ha un vettore di dimensione 10.
Sì. Allora, può provare a spengere la registrazione così vedi. Sì. Ah, sì. Che interrompe la registrazione. Perché poi interrompi.
Interrompi.
Sì.